A good architect doesn't just know how to design, they also know how to document. What's going on, guys? My name's David Tomic, and welcome back to the channel. Today we're talking about construction details. In particular, we're talking about construction details starting from the ground and working our way up. I'm going to be breaking down 5 different construction details and how you can detail them on ArchiCAD 24. So we're going to be looking at a brick to concrete slab construction. We're going to be looking at a timber to concrete slab construction. We're also going to be looking at a precast or a tilt-up concrete wall connecting to that concrete slab. We're going to be taking a look at the column connection into a concrete slab. And finally, last but not least, we're going to be looking at a retaining wall detail. So these are very critical, and I'm going to make them very generic so that anybody around the world can get a fundamental understanding of how it works in principle. Now, obviously, building codes around Australia differ. Building codes around the world differ. Building codes and standards everywhere are very, very different. So I'm not going to go into 100% specifics because I know that these are going to change on your location. However, it is going to give you a good understanding of 1, how to document it on ArchiCAD 24, and 2, what is a reasonable understanding of that detail in particular. Now, if you've noticed this brand new fresh jumper, it has just arrived courtesy of YouTube. Basically, once you hit 10,000 subscribers, first of all, thank you guys so much for pushing me across that line. YouTube actually gives you your own merch store. Now, I didn't know that. I had absolutely no idea. I've grown this channel from 0 now to over 11,000 subscribers as I record this video today, with nobody really around me doing YouTube. I basically just jumped on board and thought I would share my skills, my experience, and my passion with you guys, and it's led to something so far so successful. If you're interested in grabbing some merch, it is in the description down below. There is an architect brand if you're an architect and wish to portray your career and your passion, and there is also a future architect collection. So if you're somebody watching this aspiring to be an architect, well, make sure you grab one of those future architect shirts that will help you get there and remind you every single day of your goals. Anyway, enough of me talking about the merch and the store and the great success so far, all because of you guys. Let's turn around to these computers behind me and start documenting some construction details in ArchiCAD 24. So now that ArchiCAD 24 is open up, we're going to start by creating our first construction detail. The construction detail we're going to be talking about in part 1 is a concrete slab with a concrete footing and a double brick cavity wall. Let's get started by coming over to our wall tool here on the left hand side. We're going to keep the layer over here as walls external. Overall, not too critical because we're more so doing details, but you know me, I like my layers being correct. Let's come down all the way to the BW05 270mm cavity brick wall. Basically what that is 110mm brick, a 50mm cavity, and another 110mm brick. So as we do a construction detail, it is a section all the way through. It isn't something that we can only draw in 2D. We like to draw it in 3D. We like to work with it and create it. So let's start by clicking once, holding the shift button, clicking the D button, and typing 1000 to draw a 1 meter long wall. I'll then click again once more to finish off that double brick wall. Now with brick coursing, obviously you want to stick to brick coursing. A size brick is very typical, so 1 meter probably isn't achievable, but that's not what we're talking about today. The next step is clicking Control and the down arrow, which is going to open up a new story setting. I'm going to call this footings. If I can type properly, I'm going to call it footings, and I'm going to go minus 100mm in this case, because we're going to draw the slab as 100mm and we're going to draw our footings in 2D. So let's click OK. Moving underneath, we'll scroll across to our right panel over here, right clicking ground floor plan, going show as trace. And then what I'm simply going to do is come across to the slab tool and select a different type of slab. Now let's go simply with a 100mm concrete slab with a tile finish. Because this is brick, we are going to stop the slab right here on the internal leaf. And then we're going to wrap it back around, just clicking and holding shift to draw a perfect square on the inside. So what we'll do is, theoretically, we'll call this the inside of the house, and we'll call that the outside of the house. The next step is to grab one of these section markers. You can steal one of the section markers already on the page, or you can come down and actually draw a brand new section. So we can click on this section tool as an example, click once, drag across, and we want to look at the section that way moving forward. So now what we can do is we can either find it in our layout settings, or we can right click that section and go open with current view settings. So it's going to open up a brand new view, and we're going to see we have multiple errors straight away off the bat. So here is that concrete slab we drew previously, and here's our nice brick wall. Basically, what we want to do is we want to click Control D and drag this all the way up to the top. Now, if we measure this out, we know we have 10 mils of tiles. So once again, we want to Command D, tap the D button, and lift that up 10 millimeters. Now, if you see all these story setting lines, I absolutely hate them. So Control 7 opens up our story settings. We can simply untick all of those boxes, get rid of it, and they will disappear from our view. So now we have this detail, which is still not anywhere close to finished, but it's a good starting point. Basically, what happens with a double brick construction home is the exterior leaf runs all the way down to the footing itself, whereas the interior leaf stops on the slab. Now, this is predominantly from a waterproofing issue, and it's a very common detail. So what we're going to do is actually click once and extend that brick wall just a little bit lower to the bottom of this slab for now. Now, I'm not personally an engineer. Engineers will always give you the exact footing details, the exact slab sizes for that job, because every single job is different depending on the conditions, the wind, the soil. There are so many factors that we do not account for. So this again is just a very typical understanding of what we're going through. What I'm going to do is just start drawing this in 2D now to actually be able to explain it. So I'm going to come over to my fill tool, go to my geometric pattern, and select the structural concrete item here. So I'm going to change that to black, and I'm going to change that to white. So we have black structural concrete hatches and a white fill background. What I'm going to do here is simply go down, go 172, very traditional. I'm going to go across 150, come across at a 45-degree angle, and just simply draw this out to the underside of the tiles. So there we go. Now we have our brand new concrete slab, which we can also see has a gray outline. I don't want that. I want a nice black outline. And then I'm just going to once again extend that brick coursing all the way to the bottom of that slab thickening. Now I'm going to hold the Alt button over this fill, click once, click again, holding Shift, and let's make it a 450 by 300 footing. So that is our footing right here. Now, what we could also have is insulation inside this cavity. So if we come across to our object tool, go to the object, type in insulation, we'll get our fiber insulation 24. Now, it's definitely not going to be 300 millimeters wide. It's only going to be 50 millimeters. And we're also not going to have it on the landscaping. Let's just put it for general for now. If we tap the Control E command, it'll give us the rotation tool. So we can rotate that 90 degrees. Command D, drop that in, and basically line that entire cavity with insulation. Now, there are only two more real things that we have to consider here. From a structural point of view, there's a lot more we can consider from an architectural point of view. Basically, we need to understand where the natural ground level is. So if we come back across to our fill tool and find our earth hatch, let's change that back to a light gray. We can actually draw in our earth underneath all of this concrete, and let's come up maybe about 150 mil above that concrete footing. And we also want to make sure that we're returning our earth or sloping our earth away from the building. So let's slope it just that little bit so you can see the line falling away from the building. And I'm also going to turn off the outside perimeter line. Now, the purposes of falling the earth and the dirt away from the brick and the actual building itself is so that any water ponding next to the building will naturally fall away. You don't want water falling in towards the building, because then you're just going to have a lot of problems. So the earth should always be sloped to at least a couple degrees away from the building itself. Now, this black outline is definitely incorrect. So what I usually do is turn off that outline, select a gray line. Let's go to a solid. Let's make it green just so it stands out. Clicking once, and there we go. There's our natural ground level. We can go ahead and annotate that. We can go natural ground level. We can point to the mass concrete footing, point to the external brick wall, the cavity, filled insulation, and all sorts of other details when we detail it further. But we're not going to go into that much detail on screen, because like I said, I like to articulate this and explain everything as we go through it. But there we go. That's basically our concrete detail from a structural point of view of how a double brick cavity wall sits on a concrete footing with a concrete slab. Now that we've finished that detail, we're going to close out of that one. We're gonna keep that there as it is, but we're gonna move on to our timber stud frame detail. It is very, very similar to our brick coursing detail, but in somewhat of a different way. So basically, let's copy this slab from down below. Let's copy that 3 meters up, and we'll move one floor up by pressing Control and up to get to our ground floor. I'm gonna show that as my trace reference just so I can see what's going on. I'm gonna select my wall tool again, come all the way down to a 90mm stud partition. Now, just like we did with the brick coursing, we're gonna click on the internal, press the P button to flip that entirely, and now we have our one single stud frame sitting on top of that concrete footing. Now I'll highlight this section, click it once, click the Control button, and drag that section up 3 meters to duplicate it. Right clicking on it, similar to what we did before, we can open in current view settings. So now we're looking at the beginning of our timber frame construction, connecting to our actual concrete floor. Now, to save a little bit of time, I'm actually just gonna exit out of that, go back into our brick construction detail, open those settings, and duplicate this mass footing and concrete slab. I'm also gonna duplicate this waterproofing membrane straight away, as well as our earth and our earth line. So I'll go Control C, close that, right click, open with current view settings, and paste. Now, obviously everything isn't perfectly aligned, but that's okay. We can start simply by extending our earth hatch across and extending our natural ground level line across as well. What you'll see straight away here that's different is that footing probably won't be that big. We can drag that now back maybe about 150 mil to make it a smaller footing. Again, the engineer will detail this, and this waterproofing membrane is actually going to be very different to what we had in the brick coursing. Instead of going under this footing, we're actually going to go all the way around. So what I'll do is I'll drag that back, click the Alt button, and draw a brand new polyline going all the way around that footing and coming just past the natural ground level and past that slab. The natural ground level still slopes back just like it did before, but this timber frame wall, which I've actually explained in a completely different video if you want to go back and check out my 30-minute timber construction guide. What we do is basically have a series of timber battens, and along the bottom we would have our base plate. So if we come across and type in stud, now what would happen in this situation to the bottom of that timber floor is we would have a bottom plate actually sitting on that floor. So I'll change all of these settings here to square, solid line, black, and we'd go ahead and draw a 90 by 45 timber frame. Let's bring that to the absolute front so we can see it. Now, finally, to make this detail completed, there would be a bolt or a screw or some sort of concrete anchor sitting on top of this bottom plate, going directly into the concrete slab. Now, depending on a number of factors and what the engineer determines, it could be just your typical concrete screw, it could be chemi anchored, it could be a whole bunch of variety of things. So that will be determined by the engineer. It will be very site specific, so I'm not going to draw it in, I'm just going to articulate it so you're made aware. However, fundamentally speaking, that is a very simple structural detail for how a timber frame wall sits on top of the edge of a concrete slab, and the concrete slab then sits on a footing itself. This strip footing would wrap around the entire edge of that slab. The slab would be 100 mils throughout consistently, 85 mil depending on the engineer's detail, and then it would thicken out like I've shown in this detail here to the edges to sit on that footing correctly. Now, also inside of this concrete slab, what I haven't drawn or what I haven't shown is the small little chairs that sit inside and the Rio bars that strengthen the actual concrete slab. Again, this is determined by the engineer what size of Rio you need in that concrete slab, again depending on a whole bunch of different factors. So once again, I won't draw it in, but be aware that there is a lot more than just solid mass concrete poured into a slab. So section 2 is now completed, and we're going to move on to our concrete tilt-up wall sitting on a concrete slab. So what I'll do is, once again, I'll simply copy these so I don't have to redraw them. Control C, close that, and move across to our next one. Now, to simply move the process along quicker, I'll go Control down arrow, select both of these, Control D, Control holding Shift, pressing D, moving 3 meters up. so that we have our slab created and we have our sectional marker created as well. Now, unfortunately, by default in the wall tools, we do not have a tilt up concrete wall predefined for us. I'm not going to explain this in that video, how to create a new wall. I've explained that in previous videos. I will just simply dive into this section here and start detailing it more so in 2D to give you a fundamental understanding. So straight away, I'm going to click Control V to paste that concrete slab that we created before and the footing itself, as well as the waterproofing membrane. I'm going to move the waterproofing membrane just out of the way for now, and I'm going to extend the size of this footing down below. So at the moment it's 300, I'm going to extend that to 800 wide in total, making sure I extend the earth as well so it can be seen. And instead of 172 drop here, I'm going to have a 400 millimeter drop. Now that isn't obviously going to work straight away, so what I'll do is I'll drag that across so it doesn't disappear and push that down 228. Before I finish off moving all my earth hatches, what I'm going to do is I'm going to move that concrete footing centered 400 millimeters, and then I'm also going to extend that, let's call it 250, so it has an edge thickening. Now I can finish off my earth hatch adjustment accordingly. Okay, so now we have the commencement of our tilt up concrete panel. The fundamental principle of tilt up concrete is form that concrete panel on site and tilt it up, hence the name. What we're going to do now is I'm going to use the Alt command to select this pattern again because it is structural concrete, and I'm going to draw a 180 thick by 1 meter concrete slab. So let's drop that in there. I'm going to extend that a little bit higher just so we can see it properly, and I'm then going to chamfer these corners. So there's a number of ways you can do that. You can click on this, go to the chamfer fillet, go chamfer, and let's call it a 25 mil chamfer, and we'll do the same principle here. So that's just how a concrete panel is made. It does have the small chamfers on the edges, so you can actually draw them in. You don't have to if you don't want to, but it is a nice detail and it makes this detail a lot more clean, a lot more thought out. I'll then move this up about 25 millimeters so we can insert our packer underneath. So similar to what we did with the timber construction a minute ago, we're just going to draw a small box here, 130 by 25, and then we're going to draw an X through the middle of it. Now that concrete wall sits on top of a packer for stability and rigidity. Those packers will be about 1200 centers, depending on again what the engineer specifies in this instance. Now obviously you can't just bring up a giant concrete wall and sit it like this against a concrete footing and pad some earth next to it and hope for the best. It actually has to be physically connected so it doesn't fall over whenever there's a light breeze. Now I'm just going to make a small little cleat here. Let's call it 10 mil by 150 and do the same thing here, 150 by 10 mil. We'll connect them and drag that to the bottom. So first of all, you would have that steel cleat along the bottom. The steel cleat would have a bolt running right through the bottom here. So for articulation purposes only, there would be a bolt right there. The second bolt connecting directly into this panel wall. That would be done on site once it's lifted, whilst you would also have a metal rod coming through the concrete tilt up panel and into the concrete slab. Now that metal rod, depending on the construction methods, depending on the builder, depending on the engineer, could be cast in situ into that actual slab during the pour. It could be placed during the construction, it could be drilled out. Now finally, all we're missing is our waterproofing membrane, so we'll delete that so we can create a new one because this is very different once again. It would sit under our slab like it always does, and just like brick coursing, it would sit underneath and in between our concrete tilt-up wall and our concrete slab. Now from a construction detail point of view, that is the fundamentals of how a tilt-up concrete wall would connect to the concrete slab itself and the footing. That footing would be significantly deeper. It would be something along those lines. It would definitely not be a small footing because that concrete wall is very big and very heavy. So speaking from a construction point of view, that section of earth there would actually be backfilled after these bolts here had been installed into the footing and into the concrete wall. This rod could be a number of different ways depending on the construction of itself, but overall speaking, that is the tilt-up wall, that is the slab, and that is the detail completed. So to continue with the brick theme, I'm going to go to the retaining wall detail now. Now the retaining wall would obviously be somewhere on the site. It could be along the edge of the building, but in this case, we're just doing a simple planter retaining wall. So let's go back down to our footings layer. Let's copy that up 3 meters, just like we did before. Move another layer up and select our wall tool. Coming into our wall tool and just quickly looking for a cavity filled retaining wall. Once again, we do not have that, but I do want to draw a cavity wall in here as best I can. So what I'm going to do is I'm going to select this 110 mil brickwork with plaster on the outside so it would be rendered. So let's start in the middle of this footing, drawing one wall on the outside, simply showing it there and duplicating and mirroring it on the outside. So Control M lets us mirror, and I'm going to move that 300 millimeters across. Sectional detail open, and we can just delete that one because it's not really helping us here in any way, shape or form. We're going to start with a fill tool. We're going to go into our fill. We're going to select our structural concrete and change those settings how we had them before. What I'm going to do is actually draw a 1.5 meter wide by, let's call it 500 deep footing. And then I'm literally just going to center it to the center of that wall. Now, unlike that exterior brick wall that we did, this is slightly different. We are actually going to have approximately 300 millimeters right down the center of concrete filled cavity brickwork. So we'll have our traditional 110 millimeter brick on the outside, 110 millimeter brick on the other side, and then once that wall has been built and erected, then they will pour the concrete directly inside of that cavity. Now, altogether, that would work quite well, but it would still be very unstable. So what would happen on site is if we just change that, keeping it blue for the simple purposes of argument, there would be a starter bar, which is a metal rod that runs inside the concrete. We'll arch that so it is a nice J loop. There would be a concrete bar cast into the footing originally when it was being poured, and it would stick up through the ground, ready for the brickwork and the cavity concrete to be filled into it. Secondary on top of that, there would most likely be another Rio bar running all the way through, potentially in different directions, again, depending on the engineer's detail, to be able to strengthen and support that 300 millimeters of concrete. Now, to finish off that detail, we'll go back to this and we'll simply just draw some earth across both sides, and we'll select an earth hatch here as well. Now, depending on the actual structure and where this retaining wall is actually retaining earth, it would more likely be something along these lines here, because we want to actually be retaining earth is, well, the whole purpose of a retaining wall, so that you can have 2 different ground levels on either side. This footing here could be on this side, it could be on this side, it could be on the other side, it could be wherever it's required to be, depending on a number of factors. Again, where the boundary is, where it's retaining the earth, how the engineer details it, what the soil is, and a whole bunch of different factors. However, the retaining wall detail is typically used in this situation to be able to depict the 2 different ground levels. It is a very simple detail. It isn't something that is overly complex, but hopefully that gives you a good understanding of how the retaining wall works. Moving on to our 5th and final detail, let's close out of that one. We'll go Control C. Let's simply just copy this section across another 3 meters and move back up to our floor plan. What I'll do is select my column tool. Let's go to a steel column. We'll open up all the settings so we can go through it. It'll be an 89 by 89 millimeter steel column. That's a traditional column here in Australia. Again, all sorts of different metal steel across the world. We'll put a wall thickness in there just for fun. Let's call it 4 millimeters. It's very thick. All we'll do now is click OK and drop that column directly in the middle of our section. Now, steel columns are a very simple detail once again, and they're most likely going to be detailed by a structural engineer unless there's an architectural feature around there that is critical. Just like all of the rest of these details, they will be predominantly provided by the structural engineer. It's our job then to go and enhance them from an architectural point of view, but without knowing the fundamental basics of how this works, you won't be able to do anything architecturally speaking. So opening up this sectional view with open current view settings, we can see our column coming straight through, and let's go ahead and draw a nice footing here like we did for the retaining wall itself. So let's draw a 600 by 300 footing. let's drag that to the center of our column right here. And then what I'm gonna do, let's drop that 25 mil for the instance now. Basically what would happen with this steel column to the footing connection is we would have a base plate that would look something along the lines of this. I'll draw it very mediocre just so we can get an understanding of what that base plate would look like. And then we would have a little bit of grout filled in underneath this section of that base plate. So the grout would be on top of that concrete footing. Then there would be a base plate for that steel column, and then you'd have the steel column up above. What would then happen is there would be 2 bolts bolted on site as that steel column is put into place. Those anchors there, unlike the timber, would most likely be a chemi-anchored bolt because it is a structural element that we're talking about. So the chemi-anchored bolt is something, again, depicted by the structural engineer, not necessarily defined by the architect, but it's something that we need to be aware of. Is basically a pre-drilled hole, a bolt goes into that hole, and then it is filled with some sort of chemical resin that expands, fills that hole up, and makes sure it is a very snug fit. From a sectional architectural point of view, this detail is horrendously ugly and industrial. This might be a flat bar plate, so instead of looking a little bit curved, it could be a flat bar plate like I've just shown there. So it is easier to fix that bolt too. Again, depending on what we detail, what we specify, but you'd still have the bolt heads sitting above something like that. So unless you actually look at the engineering details and look how it needs to be connected in that particular area, you're not gonna know what to do from an architectural point of view. Now, we could box that out, we could plaster it, we could hide it inside a concrete wall, we could hide it inside a brick wall, you could do a number of things to make that column disappear, but you just have to be aware of that detail here. So that's why I've selected the column sectional detail, because it is more of an architectural detail that needs to be considered than anything else. Personally speaking, what a nice architectural detail would be a simple recess into the concrete footing. So let's recess that. We'll call that 25 millimeters and select all of our column and our base plate, allowing that to be recessed into the concrete. So it's a nice flush detail, and all you have to worry about then is the bolts. We can get flathead bolts, we can then drag that down something like this, have very small flathead bolts so it isn't seen, and then potentially if you have some sort of sheeting covering over the top, be it tiles, be it carpet, you might be able to hide that if the bolts are good enough and you actually detail it properly. But without drawing this sectional detail, you'll most likely have a very ugly connection from an architectural point of view. Anyway, that's all for me today, guys. Thank you so much for watching. I hope you enjoyed the video. I hope you learned some critical and valuable information out of it. If you did, make sure you check out the links down below. There is a Discord chat where you can actually download this ArchiCAD file for yourself. You have to sign up as a Patreon legend level member, but that means every week I do a tutorial, you get that ArchiCAD file to download, save, and understand further, use it however you wish. If you enjoyed the video, make sure you smash that subscribe button, and don't forget about the like button. The like button, somehow or another, believe it or not, helps with the YouTube algorithm, helps me continue creating these videos, and helps other people learn valuable information. Like I said, that's all from me today, so I will see you next Monday.